we are here to talk to you a little bit about building a platform framework, lessons learned from developing a multi-clustered Kubernetes operator. So we are from Syntasso, and we work on Kratix. That was one of our original stickers. Let me know if you know the joke. I don't really get it. So I'm Kat Morris. I'm the product manager here at Syntasso. I've been here for about a year and a half, 2 years now. Before that, I worked on platform products at ThoughtWorks and other companies, working for 5 or 6 years in this platformy Kubernetes domain. I'm here with Jake.
Yeah. Hi, I'm Jake. I'm an engineer here at Syntasso. Been here almost 3 years. Prior to that, I was working at Weaveworks and all their open source projects.
And we're going to start with a little story that's definitely not based on fact or any of our previous experiences at all, and we've definitely just made it up for this conference talk. There's a new product in the market, a new startup called I'm a Little Teapot. And Jake and I have been roped in as new members of their infrastructure, DevOps, SRE platform team to start building out ways for their developers to be more efficient. So we start with our teams. They need a way to deploy workloads, databases, anything into environments. How are they going to do that?
Yeah, just a single Kubernetes cluster. It's a pretty easy thing to do when you're getting started. Maybe you go to the cloud provider of your choice, do some ClickOps in the UI and get a cluster, and you're good to go.
OK, we quickly realized that one cluster is not really going to do it. We're going to need production. We're going to need development. They're going to have different requirements, different scales, different compute power. Still pretty easy to manage, right?
Yeah, not too difficult. Just do the same steps as before, get another cluster. It's a bit more operational overhead, but it's not too intimidating.
OK, we've had an outage. We've realized we need to be a little bit more robust and resilient. We want to look into availability zones so that we've got a replica of these things across our different environments now.
Yeah. OK, you've just doubled the number of clusters again, a bit more operational overhead. You're starting to feel a bit more like a platform team looking after these clusters. Maybe you start to think about other tools in the ecosystem you could use to manage these clusters, but it's still early days.
Sales have been great this year. We were originally an EU-only company. Now we've just sold a massive amount of work to the US. They have way different rules, way different regulations. We want to keep this data completely separate. Let's put things in different regions now.
OK, the complexity of the platform is definitely creeping up. You're definitely going to want to start using some tools to manage the clusters, maybe a Terraform, maybe using some open source projects like Cappy or any of the tools that are available in the ecosystem to manage the clusters.
OK, there's an ML team that's come up to me. They've got a bunch of free Azure credits. They've realized that they've spun up a bunch of Kubernetes. Looks pretty much the same as what you've done in AWS, right? Can you put that all under the same platform now?
Yeah, it's definitely adding the complexity a lot, right? We know the different clouds all offer Kubernetes, but they have different authentication models. They all have subtle differences in how they do various parts. So, it's not easy managing multiple clouds. Definitely the complexity of the platform is growing.
And it grows even further when we acquire a new ML company that are all based on-prem. They wanted complete control to build out their models. They've also told us it's just Kubernetes.
Yeah, this is definitely getting complicated now. Multiple clouds, on-prem, it's a lot of complexity to manage for a platform team.
And this problem grows even further when you get bigger and more effective and more successful as a business. So you're not just acquiring different teams. Your teams that are working already are doing weird things with your software. They're pulling out Lambdas. They're working on that on-prem environment with not just those Kubernetes clusters, but you've got virtual machines. You've got your databases on there. You're thinking about edge compute now, maybe Terraform, Puppet, Ansible, different ways of orchestrating these things that are all being managed in different ways. And it goes a little bit crazy.
So maybe a quick show of hands of anybody else in the audience experienced this process of a slowly building platform, more complexity?
Oh, shoot, like half of you.
So, cool, awesome.
I'm sorry.
So this is why we built a framework called Kratix. It's an open source project to try and make it easier to build better platforms.
And we've actually learned a lot while doing it, not just in the Kubernetes space, but in the product space and all the other technologies we work with. So we want to give you some lessons, some do's and don'ts, so that you hopefully don't make the same mistakes that we do, and hopefully learn something. And the first don't that I want to talk about, and it feels very relevant given where we are today, is don't reinvent the wheel, use the ecosystem. You've probably seen this about a dozen times already, this slide. This is 215 projects I was able to count. And they're across all different types of areas. So you've got observability things, you've got deployments, all sort of Kubernetes related or adjacent, and they solve problems that exist already. They've done things for you, done it the hard way, so that you don't have to rebuild the same mistakes that people have already made. But something to remember, given how complicated it is how do you pick the tools to use? How do you choose the right framework? And in our case, we're a platform. So I want to read this. I haven't actually seen it this week. This one usually comes out all the time, and it's the Evan Bottcher definition of platforms. And he says that a digital platform is a foundation of self-service APIs, tools, services, knowledge and support, which are arranged as a compelling internal product. So this means we should be thinking about things a bit more holistically, and also remembering what are those things that we want to provide as a service, what are the tools that make sense for our platform users, and how do we want to provide that to people when we pick those things from the ecosystem that already exist. Otherwise, you could end up with a model like this. And this is something that I have personally fallen foul of myself. And you try and do everything that a platform provides on your own. You try and build your own GUIs and interfaces for your users because actually you think you know best about what they want. You try and incorporate all the different novelties of the CI/CD systems that exist in the ecosystem, maybe not really knowing which one's best for you. You try and use your own infrastructure as code, or even you buy a product that claims to do all of these things out of the box for you, easy peasy. And you end up looking like the gremlin after midnight that's covered in water. So instead of trying to do it all yourself, you can innovate on top of that wheel. So we've got all of these ecosystem projects already. What are you going to add that's new? And for us, in Kratix, we've got this concept of a promise. And this is your way of providing anything as a service. And we think it's got some key bits in it, like the API, how do people interact with the promise, some dependencies, workflows, and rules about where it ends up. And how we've built on top of the wheel is this is just a YAML, just a CRD definition, looks very familiar to people in the ecosystem. And it means we can fit really nicely. So we've got this specialism that we think we have as a product, which is around platform orchestration. So how do you stitch all of those lower level infrastructure components together and provide them as a service to your end users? This is where we've got our specialties. So that's where we want to put all of our energy, and we're a nice fluffy gremlin in there, while leveraging the power of Backstage, Port, Headlamp as GUIs, while making sure that the orchestration is done by Kubernetes, because that's way better than we could do it and has a massive wealth of knowledge built up already. And we're never going to be a cloud, so why would we bother doing something as good as AWS, Azure, or GCP already? However, we've tried to get rid of some of that complexity, but we still have to think about multi-cluster. So don't underestimate the complexity of going multi-cluster, because Jake's going to tell you some of the challenges that come with that.
Yeah. So when building this framework, we wanted to support deploying workloads to multiple clusters. And we started out with a simple use case we've seen a lot. Often developers get access to a Kubernetes cluster. They start deploying some operators to it, maybe a Kubeflow, and then they start using that operator to get some value. So here to train their machine learning data. And this is pretty great. They start consuming the platform more and more. They're a very happy engineer. They start using the cluster even more, installing more operators, getting more value out of Kubernetes, and using more things in the ecosystem. This then grows. You have multiple people across multiple teams all using Kubernetes to get value. And it's pretty great. But you realize having a cluster per person doesn't really work. So then you start to go multi-tenant. You have different people installing different operators, different software stacks into Kubernetes. And you start to hit some problems. People start requiring different things in the cluster. People want to upgrade the Kubernetes cluster. Some people accidentally delete each other's stuff, which I'm sure we've all had. And it quickly becomes a bit of a mess. So our main idea is that you don't want to be giving your developers direct access to Kubernetes to do all of these things. You'd rather just give them access to a platform, and the platform will take care of it for you. So the basic idea is a platform engineer will want to provide something as a service on the platform. So in this case, maybe they want to provide Kubeflow as a service. So they would go to the effort of writing, what does it mean to run Kubeflow at my company, encapsulate that in a promise like Kat was talking about, and install it onto the platform. So what does that mean? Well, in this case, Kubeflow being installed onto the platform should go and schedule out Kubeflow to all of my Kubernetes clusters where I want Kubeflow to run. Now, there's some requirements to that, right? It might be Kubeflow only runs on a case of a particular version, or only clusters that have particular GPU nodes. But that's what we need to support. So in a world where this works, this will be great. A customer could come to the platform and say, hey, train this model for me. You, the platform, can then decide, OK, I'm going to schedule it to this cluster based upon the requirements that they've set. And this is great. You can then get loads of people come into the platform saying, hey, do this thing for me, give me this service. And the platform can take care of the complexity of deciding where to schedule it to. So this is the world we wanted to get to. And then we started thinking about, OK, how do we want to do this? How do we design a framework that handles the scheduling to multiple Kubernetes clusters for you. So we started off with a pretty simple idea. It's like, OK, we want the platform to have access to these clusters. You could just do it with the API, like give the platform cluster all of the credentials to talk to all of the clusters in your fleet. There are loads of tools in the ecosystem today to manage this. You could use things like Comada or Argo CD, but they all have some drawbacks. In our case, we didn't want to rely on connectivity to all of the clusters. Maybe you have Kubernetes clusters running on the edge. Maybe they're running in air-gapped environments across different clouds. And having a central place that has credentials that can talk to all of them is not going to be very realistic. So then we were like, OK, GitOps is a very powerful tool. It's being very widely adopted. What if we just said, rather than having connectivity to these clusters, we just say, well, what we're going to do is orchestrate writing the files to the correct Git repositories or S3 buckets that can then be synced to the remote clusters by the tool of their choice. You know, they could be running Argo, could be running Flux, they could be running their own loops. They know how to read the files from Git and converge. But it's pretty flexible, right? We don't have to have connectivity. You can imagine somebody literally going into an air-gapped cluster, plugging in a USB stick, copying some files across to the Git directory, and everything converging. So we were pretty happy with this, and we realized we need to start to find a way to distinguish these clusters from each other. How do I know what this cluster is good for? So then we were like, OK, this has been solved a little bit. You see nodes within a cluster. Nodes have labels. Pods select where they want to go to based on the labels on a node. This is quite a good idea. We decided we would reuse this for our scheduling. So here you could say, this Kubernetes cluster belongs in this region. It has GPU nodes enabled. Maybe you say what version it is, what operators deployed. Just a way to describe the usefulness of these clusters. So coming back to our initial use case, this was pretty good. You know, a platform engineer could come to the platform and say, hey, schedule this operator, so Kubeflow as an example, to all of my clusters that have GPU nodes enabled. We could then filter and go, OK, I know these certain clusters have this label that says they have GPU nodes. Let me go and write to my state store, to my Git repository or my S3 bucket, the files to run Kubeflow. And then the GitOps tools on these clusters can pull the files and then run the code. And it's good. My fleet has been prepared. It's now ready to accept requests from the user. So then the user can come to the platform and say, hey, train this model for me. And it's great. The platform then says, OK, I know which clusters have GPU nodes. I know which ones have Kubeflow installed. Let me go ahead and take this workload, write it to my Git repository, and have that synced down. And everybody's happy. But we quickly realized that while this was a really great idea, there are more complicated use cases that start to come up. So let's say you want to train this model, and you want to have a dashboard set up for it. But you don't want to send the dashboard to a cluster that's really expensive that has GPU nodes. You'd rather send it to a separate cluster. Maybe it's a bit cheaper. And with the way we designed it to begin with, that wasn't possible because we were only thinking about scheduling one document at a time. So then we had to continue our evolution and go, OK, actually, we want to support scheduling multiple documents to multiple different places all at the same time for those more complicated workloads. And you can imagine this for a variety of things, like running a database multi-cluster. You might do like an agent to one cluster, an agent to another cluster. And it really started to enable a lot of more complicated use cases. And then we realized that actually this GitOps idea is pretty great. And it's actually been widely adopted by other tools. So I think some of the obvious ones, like Terraform and Pulumi, people know that you can commit Terraform files or Pulumi files to repositories and have them be converged by other tools. But this actually applies to a lot of things. So even Backstage, for example, you can declare a place to go read in Git all the files from, and it will show it in Backstage. Or the same for Ansible Tower. And we realized this is actually a really good idea. Like, you don't have to use GitOps just for Kubernetes. You could use it for other services. So that's what we did. We made our scheduling more open-ended, more flexible, and said, OK, you can imagine a world in which we send a machine learning model to one cluster, we send a dashboard to another cluster, or we send a request for an S3 bucket to a Terraform Git repository, and we send a request for a component in Backstage to another one. And we're getting this nice flow of everything's being declared in Git. I can see everything in Git, and everything's being converged by these remote clusters. So that's the sort of the journey we went on. We thought it was going to be really easy. We realized that actually going multi-cluster is pretty complex. So after this, we were like, great. The next mistake we made is that we thought we could reduce, the next lesson learned is that do try to reduce the complexity of things that are in your control. So in this case, we built this system, write files to a Git, have it be synced by the remote cluster. But how are we going to get information back from that cluster? A real simple first pass might be, OK, you deploy an agent to that cluster, you give it access to an API that's running on the platform, and it pushes data back. Or maybe you have it talking to a remote database somewhere else that's then pushing data back into the platform. But we realized that actually this is changing the architecture of our software quite drastically, right? Before we were saying we don't need connectivity, the Git repository or the S3 bucket is the only source of communication, and doing this would introduce more complexity. So we're like, okay, how can we reduce the complexity of the things that are in our control? Well, why don't we just use the same method for communicating data to the cluster to communicate data back? Now, this ended up being quite a simple solution. We managed to work on it very quickly, get it to our customers very fast, and start getting value very quickly. We're going to learn as it scales. Does this continue working? But we didn't spend months developing a feature that didn't work. We did it in days rather than weeks and months.
Mm-hmm. There are times where we didn't do something so efficiently, though. Time to air some dirty laundry. This is how we design things internally. Well, used to. So we had a customer come to us and talk to about a feature that they wanted. Oh, I've got this promise. I need to upgrade it. How do I know what the current version is? How do I know which version it's going to? How do I make sure that that's all effective? And we were like, okay, cool. We've seen this problem before. Versioning can be hard. Dependency management on those versions can be hard. Let us think about it. So we started with one of these white boxes, and that was original versioning conversation. And then we were like, oh, wait. Once we've got versioning, how do I make sure that the dependencies are right and that I depend on the right version? That was white box number 2. Then once I've got those versions chained up, what happens if one upgrades, and how do I manage those upgrade cycles? And if I want to upgrade for a patch, is that going to be different from the other one? That's white box number 3. And that's when we kind of called it, and we were like, hang on, we could keep going like this. It could be turtles all the way down, boxes and boxes of us thinking about something before we deliver anything. So we're like, right, okay, let's go back and do something simple. Maybe not so much. I went back in time and looked over these boards and saw how much people were working on these things. We had 7 people in our company for 2 weeks working on this design phase, and then another 3 weeks working on the execution phase. And that's when I was like, okay, 5 weeks worth of work. Let's see if this has got the results we want. We released the feature, and it was absolute crickets, complete silence for 12 months. And then we got an absolute onslaught of feedback from customers who were using this feature that we didn't realize. At which point, none of us could remember or even read what was on any of these boards, so we had no idea what was going on. That was maybe a mistake. So what did we learn from that? So as opposed to the health checks example that Jake was talking about, where we got pretty fast feedback, what did we learn? Never listen to your users. No, I'm lying. Kidding. I'm a product manager. I'm not allowed to say that. I will be lynched by Marty Kagan if I tell you never to listen to your users. Not right. Really, we should have probably been listening a little bit closer, because if we'd have spoken in a bit more detail to a few more of our different customers, we'd have realized it's not quite the burning issue that it sounded like at the beginning. Okay, instead, do the fastest thing to unblock your users. Maybe that would have worked. If we'd have done something immediately within 2 days of them asking us, maybe they would have used the feature and given us feedback. That's also probably not going to work. Then you're going to end up with a load of tiny bitty features that you can't maintain and upgrade over time, and it's going to be really painful to manage. This was my CEO's Secret Santa present in 2024. It is a framed picture of a quote that he says on probably a daily basis. If any of you have had conversations with him this week, he's probably said this to you as well. He's known for it. And it's life is a series of prioritization exercises. There is an infinite amount of work that you could be doing. So many improvements you could be making to your platform, to your products, in your life, everything. But you have to choose what are the right ones for you to do at that particular time. So he is constantly reminding us of this, of like, how do we make sure we are working on the most important thing right now? And we do that by prioritizing our user needs with our wider goals. Because our user needs will tell us things like, we need versioning. But our wider goals as an organization will help us figure out, is that something we want to do right now? Is that something we want to do in 2 months, 6 months? And fit in with a wider picture about what we are doing. And how do you figure that out? You remember why you started in the first place. So that picture that I showed you at the beginning, where we were talking about the complexity of managing all of those different clouds, on-premise services, Terraform, edge computing, Ansible, that complex landscape, is why we started our company and why we built Kratix in the first place. Because we wanted to make it easier for the application teams to have a unified interface so that they could have that interface layer. But actually, there are a lot of products that do that already. And we were all platform engineers. So we wanted to create Kratix to add abstraction layers so that your platform teams can build something for those users that they can have through this unified interface without having that complexity on the user side or the platform team side. So you can both platform engineers and application teams get that unified experience. Oh, and also other platform orchestrators are available. I'm not going to tell you who they are, though. But drumroll for the biggest lesson that we've actually learned so far.
Never assume your users actually know Kubernetes. Kratix builds upon Kubernetes, it extends Kubernetes, it has operators, it has CRDs, and we thought that people would just take this, run with it, and understand it. And we realized that that's not the case. Loads of companies are still early in their journey on Kubernetes. Loads of people don't have that much expertise in their organization on Kubernetes. So yeah, this is a painful lesson that we learned, that you need to try and make sure you don't bake that into your product.
OK, here's the summary slide. Don't reinvent the wheel. There's a massive ecosystem out there, particularly in the Kubernetes space, but do innovate on top of that wheel. Add your special sauce on top of whatever you're building so that you can make something better and build up all those projects that you're building on top of. Don't underestimate the complexity of going multi-cluster. Jake's point, I've counted it was 30 slides, so that proves how complicated it can be to go multi-cluster. But do reduce the complexity of the things that were in your control. So if you want to go multi-cluster, pick the bits of it that are going to be powerful for your organization. And then don't just build things you think are going to be great, because you're probably wrong. But do remember why you started building in the first place. Because even in my story, we said didn't get usage for 12 months, but we did at the end of it. People were using that functionality and learning from it. So remember why you started, so that you can build the things that people want. Just make sure you do it at the right time. And also never assume that people actually know Kubernetes. I don't think I can shout this hard enough. It's really, really difficult and complicated. Thank you very much for listening to us, everybody. So if you want to learn more about Kratix as a product, or just want to chat to me and Jake because we're fun people, we've got a booth. We're at 641. We've got card games, so you can come play card games with us, and one of our colleagues will run you through that. And also, if you want a demo, you can have a demo. Are there any questions? No. Jake and I will hang around if people want to ask us anything. We're here.